Hey guys, today I just wanted to go through Fourier transform infrared spectroscopy and specifically walk through the specific machine located in the undergrounds in the solid state science department. So this is essentially all I'll be going over today, and I'll just quickly run through the concepts because this should already be pretty well known to the viewers out there, and honestly all the underlying concepts can be found simply by using a search engine. So we're going to start with what is FTIR, and then we're going to go into the sample preparation, and then conclude with the data analysis. So in FTIR, you're just trying to obtain an absorption spectrum of data from your sample by using a beam of multiple frequencies so that you would obtain peaks that show which part of the frequency was absorbed by your sample. This can give someone the information about the chemical binding structure by using the data references. So it can identify both organic and inorganic compounds. It's great for thin film analysis, adhesives and coating especially. And it can also do, another thing is it can do is determine the degree of crystallinity in polymers. Here is the beam in the image. It's generated by starting with a broadband light source. It contains the full spectrum of wavelengths, like I said earlier. The light shines into a Michelson interferometer, which has a certain configuration of mirrors, which is moved by a motor. And as the mirror moves, each wavelength of the light in the beam is periodically blocked, transmitted by the interferometer. Due to wave interference, different wavelengths are modulated at different rates so that each moment the beam coming out of the interferometer has a different spectrum. And in computer processing, it is required to turn the raw data, the light absorption for each mirror position, into the desired result, which in this algorithm that does that is called the Fourier transform, hence the name of the ticket. So it's your first day as an undergrad research assistant, and Anwar ends up giving you a sample that he wants you to analyze and come up with an accurate estimation of what the sample may actually be. He gave you some Scotch tape as a little reference, a little standard to use. So yeah, it's pretty helpful. You did well in your classes, unlike me, so you understand that having a standard and unknown means you have some leeway as to what machine you want to use. So after walking around ASU and the Goldwater undergrounds and getting lost for a couple hours, you come across a pretty cool room. It has an FTIR. You kind of remember what it does, so but there's no one around. But you think it'd be best to use it now, so that way if you do screw up, you can just walk out. No one will notice. It's a pretty good plan. Probably won't get caught. So continue. So this is just a quick slide of the overall FTIR machine, along with Brahman at the side of it, which is located right, at the right side of it. Which we are not talking about today, but in case you were wondering, one would use that specific machine to focus one beam of one frequency on a small specific spot to get a relay of absorption spectrometry. So in case you can't use FTIR or the preparation of a liquid sample is too long and obnoxious for you, you can use Raman. That's pretty much what you would use it for. So first, you're going to put gloves on, or not, it's your call. Remember that it should be under a vacuum, so you locate the pressure button, which is labeled as the letter P, and you check to make sure it's set really low. You perform a safety check to make sure everything looks good. So the nitrogen cylinder has, the nitrogen that's actually supposed to be in it, and it's not empty. The beam splitter is installed by looking under the round lid. Make sure you note the color as to which one is being used, red, brown, yellow. So then you vent the system by simply pushing that down arrow button followed by enter. Also make sure to not touch the beam splitter when you're looking at it. Once the system is vented, you may proceed to make sure it's under the diamond ATR module. Once this is all set up, you can lift the metal lid straight, and I do mean straight up, without knocking or budging anything over. You then lift the knob closest to you and gently lift the arm towards you, and then clean and wipe down the surface with a chem wipe. And then you can put the knob back and push down the knob, which is nearest to you, and tighten it, but not too tight, kind of like a cozy fireplace tight. Make sure the top is not touching the diamond, and place the lid back down and evacuate your system by pushing the up arrow and then and then enter to get a blank run. So you're going to start the software on the computer by clicking on Opus, hack into the program real quick, or just type in Opus as a password, and go to the basic tab and select the run you are doing. Check the signal. It should be above 2200, hopefully. That's how you know it's working correctly. Then you adjust the number of background scans to your liking, and once the blank has been run, you can vent the system. Then you can lift the lid straight up, take a very small size of your sample, so that's just enough to be over the diamond. Any extra is really just unnecessary, just gives you a higher chance of contaminating parts of the machine. So you only want to use what you need to use. Then you can place the puck on the sample with the arm to hold it in place and twist and screw the knob down again and close the lid and evacuate the system. Remember, this is your Scotch tape, so you should be smart enough to know the magical chemical bonding structures and Scotch tape to note and the spectrum that is going to be returned to you, so you can use that to analyze your unknown sample if you have it. And then here's just another quick picture if you'd like to see the complexity of this machine. Specific image represents the evacuating portion of the test, as you can tell. Those are the up and down arrows, and the enter. You don't really use the escape at all. The FTIR machine outputs the wave number in either the transmittance or the absorbance at each wave number. Absorbance can be linearly scaled with concentration, while transmittance cannot. Thus, absorbance spectrum is more commonly used. It can convert transmittance to absorbance and vice versa using logarithmic operations. In IR spectroscopy, the correlation table is used to compare your wave number and wavelength data to those of common functional groups and chemical bonds. So correlations out there, so you can just choose the one which best fits your needs. All the peaks are important, not just the largest ones, so make sure you do try to identify the smaller peaks as well. Once the bond types are extracted, the compound identification can begin. So specifically, this is Scotch tape that Anwar lent you, and as you can tell, once referencing to a data standard, the type of bond, the type of vibration can be obtained. Essentially, stretching is just when the bonds only move in a longitudinal direction. Bending, meanwhile, incorporates 4 subtypes motion, which are rocket, wag it, scissor it, and twist it. And those just pretty much exactly how they sound. Again, so there's a thermoscientific book that's located in the FTIR room, which has a large spectra to look at. As well, NIST also has its own spectra you can look at as a standard. And so in this specific scenario, you realize that the unknown sample that Anwar gave to you must be polyethylene based on its simple carbon-carbon bonding. So you just vent the system, do the necessary steps to take out your sample and exit the program. Of course, you saved it and printed it, hopefully. So just to conclude, FTR is best used for samples that lie in the near and mid IR regions. Sample preparation is both easy and efficient to use as long as it's either a powder or a solid. Liquids, on the other hand, are quite messy and difficult, so it's best to look elsewhere to analyze that liquid sample. And this method is, of course, it's pretty reliable method for obtaining your chemical bonding information for a given sample. Here's a list of our references, and I and my team would just like to thank Dr. Emmanuel Signard for sharing his specific knowledge on the FTIR machine located in the Center for Solid State Research at ASU. And here's a picture of my dog cuddling a panda. And thanks for watching our presentation.